We see the magic of AI on our screens every single day. You've got the chatbots, these incredible image generators, but behind all of that digital wizardry is a massive and growing physical footprint. And, well, it's creating an energy crisis that most of us never even see. Right here, this is where AI actually lives. These huge, sprawling data center campuses are basically the engine rooms for our entire digital age. They are packed with thousands of super powerful servers, all humming away 24/7. And they are, to put it mildly, unbelievably power hungry. So, take a look at this number, 2,250 megawatts. That is the planned power capacity for just one new Amazon data center campus in Indiana. It's a totally staggering figure, but what does it actually mean in the real world? Well, to wrap your head around that single data center could use as much electricity as 1.5 million homes. That's potentially half of all the households in the entire state of Indiana. Think about that, for just one project. And this is not just a one-off, not by a long shot. Globally, the amount of power data centers need is on track to more than triple by 2030. And this insane growth, it's being driven almost entirely by the rise of AI. So, this brings us right to the heart of the problem, AI's absolutely insatiable demand for power. And this incredible thirst for energy, it's putting a kind of pressure on our power infrastructure that it was never designed for. It's leading to a severely strained electric grid that is, right now, reaching a breaking point. Just look at this. This is for Northern Virginia, which is basically the data capital of the world. That little flat line on the left, that's the historical power demand. Now look at the projections. That is not a gentle slope. That's a cliff face. It's a wall. And utilities are sounding the alarm, saying demand is just flat out outpacing their ability to supply the power. And let me be clear, this isn't some far-off future problem. It is happening as we speak. Right now, the wait time to connect a new data center to the grid can be 5, even 10 years. And to meet this soaring demand, some utilities are actually proposing we go back to building fossil fuel plants. That could wipe out years of progress on cutting carbon emissions. So, this crisis is forcing the tech industry to get creative and look for some pretty radical solutions. And that leads to a really surprising turn: small modular reactors. So what on earth is a small modular reactor, or SMR? Okay, first, forget the giant cooling towers you're probably picturing from old power plants. These are a whole new generation of nuclear reactor. They're designed to be small, built in a factory, and then just assembled on site. And, critically, they have these advanced safety features like passive cooling systems that don't even need outside power to work. I mean, the contrast is night and day. Traditional plants are these massive, custom-built projects that take decades to finish. SMRs are way smaller, they're factory-built, and you can scale them up by just adding more modules as you need them. It's a totally different way of thinking about nuclear power. So, the big question, the billion-dollar question, is this: are these SMRs really a match for the unique energy needs of AI? Okay, so a lot of you are probably thinking, hold on, why not just use renewables like wind and solar? And that's a great question. The key difference here is consistency. AI data centers run around the clock 24/7, and they need constant, reliable power. Renewables, they're intermittent, they depend on the weather. But SMRs, they provide a steady, nonstop stream of carbon-free energy, and they do it on a much smaller piece of land. So the thinking goes like this. By building an SMR right there on site, a data center could just completely bypass the clogged electrical grid. This would give it its own dedicated, nonstop, carbon-free power source that you can scale up as the AI campus gets bigger. It directly solves some of the biggest headaches facing AI infrastructure today. And listen, this isn't just some theory or a crazy idea. The biggest names in tech are already making moves. Microsoft is actually hiring nuclear energy experts. Amazon has invested in developing SMR-powered data centers. The industry is clearly taking this path very, very seriously. But of course, it's not that simple. It never is, right? SMRs are definitely not a silver bullet, and the path to a nuclear-powered AI future is, well, it's filled with some really complex hurdles. The whole process is just incredibly complicated. If you want to build an SMR, you have to run this multi-year regulatory gauntlet. We're talking rigorous federal licensing, exhaustive environmental reviews, a whole unique set of liability laws, and, of course, a long-term plan for managing nuclear waste. It is a slow, expensive, and really complex path. So, all of this brings us to a really critical moment. Let's call it AI's energy crossroads, where we are facing some pretty difficult choices about where our technology goes from here. At the end of the day, it all comes down to this one paradox. The AI revolution, this incredible leap in digital innovation, is running headfirst into a very real, very physical energy problem. The demand for computation is creating a demand for electricity that our current systems just were not built to handle. And that leaves us with a final and pretty vital question. It seems like our choice is between slowing down innovation, building more fossil fuel plants, or maybe embracing new technologies like nuclear. So when it comes to powering the future of AI, what price are we as a society willing to pay?